1, okay? Example number 1, we're going to first do by hand, and then we're going to verify using Desmos. The reason being is that it's a quadratic linear equation, and we all should be comfortable graphing linears, okay? It's Algebra 101, okay? So up first, it says, this is our function. P of x equals 1/2 x minus 3, right? 1/2 x minus 3 is a simple linear equation. With linear equations, it tells me everything I need to know right off the bat to graph. How do I graph a linear equation? I do y-intercept. I start with the y-intercept. And what is the y-intercept? -3. So I start at -3. After that, then what I do? I use my slope, my rise over run. So my m is 1/2. So what is my rise? What's my run? 2. It's linear. It's just good old Algebra 1. Plot my little points that I can, and I'm going to draw the best straight line that I can. All right. So here is my P of x. Are we comfortable drawing P of x? Okay, these are the notes you picked up yesterday, in case you're looking. Like, what are these? I said make sure you have them out. All right. Now, it says that we're going to, let me hide my instruction bar here. Okay, it says consider the absolute value function a of x equals absolute value of x. Define the function h such that h of x equals a composed of p of x. What is an algebraic representation of h? So it wants us to make a new function, and that new function is going to be h of x. H of x equals a composed of p of x. That means a with p of x substituted in, correct? So what am I graphing? What would that look like? Well, that means when I'm graphing y equals, instead of just absolute value, is the absolute value of 1/2 x minus 3. That's what we're graphing. And that's because it says a of x equals the absolute value of x. And it says h of x is the composition. It's a composed of p at x. So it's telling me it wants me to take p of x and plug it into the absolute value. Does that make sense? Okay. So we're going to do this by a point-by-point situation from left to right. Is that cool? All right. So up first, we have -8. So if I plug in -8 into this equation we just created, what happens? Well, 1/2 of -8 is? -4 minus 3 is? -7. Absolute value of -7 is 7. So at -8, I'm now at +7. So now we're going to go on to our next point, which was at -6, -6, right? So I'm going to plug in x equals -6. If I substitute in x equals -6 to this absolute value function, we're using the previous points that were given. So instead of making a table, I'm just using the points that are already on the line, right? We're using their x values. So the x value here is -6. I'm going to plug in -6. 1/2 times -6 is? -3 minus 3 is? Absolute value of -6 is? 6. So we're now here at 6. Between those 2 points, have you noticed something? It's taking a negative and turning it into a positive. Our x's aren't changing. Our y's that are negatives are now becoming positives. Do we see that? So what's going to happen at -4, -5? There we go. We're going to be at -4, 5. What's going to happen at -2, -4? -2, 4. What happens at 0, -3? It's going to become 0, 3. What's going to happen at 2, -2? It's going to be 2, 2. What happens at 4, -1? 4, 1. What happens at 6, 0? It stays the same. And what's going to happen at 8, 1? What do absolute values do? They make things positive. So if I'm already positive, is it going to change me? No. If I plug in 8, what's half of 8? What's 4 minus 3? Is it still a positive 1? Yes, absolute value. If I'm already positive, it's not going to interfere with my happiness. I'm going to stay positive, okay? So here is our h of x. So this is your h of x. So it says, what happened? So how did we end up looking like this? Well, mathematically, what took place? We got happy in a sense, right? But mathematically, what happened for all of our x values? They got the absolute value. So for the x value, x less than 6 of p of x, all y values became positive, right? Is that a fact? So originally we had p of x, and all of the values of x that are less than 6, all of their y values became positive. And the reason for that is absolute value. That's because we weren't taking the absolute value of the x, we were taking the absolute value of the y, of your output. Okay? If it's set up like this. Okay? So, conclusion, if the function is inside of the absolute value, we're changing its y values. Does that make sense? Good. Describing here what took place. All y values were changed, and then graphically, our whole graph is now above the x-axis. So h of x is above the x-axis. Why is it above the x-axis? Because all y values are positive. Okay? All right. We do. All right, so next one, same graph, part F. So it says here, we're going to consider still using this guy. A of x is the absolute value of x. Define the function k. Well, k is saying we're now going to have p composed of a at x. What is the algebraic representation of k? So k says k of x equals p composed of a of x. What does that mean I'm doing now? Making another one. I'm making another one. There you oh, look at you. We're going to do the absolute values of the x's. So graphically, it becomes y equals p absolute value of x. So everywhere in p, there's an x, it becomes an absolute value. So it becomes 1/2 absolute value of x minus 3. Well, this is just an absolute value equation, right? Which is what your 2A.3 was over. And how do you graph an absolute value equation? Do it. Yes, you do it. How do you do it? Your A, your H, and your K. This is just an absolute value, right? So what is my H and my K? So my vertex is at 0, -3. Check. I can do that. And then my slope is 1/2 because A equals. So from 0, -3, I go up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. That's the right side. I thought you saw me using them, so it was implied. Okay, to get the other side of the absolute value, I'm going to do the opposite, right? I go up to the left. So up 1 over 2, up 1, 2, up 1 over 2, up 1 over 2. So now we have that. What did I do to get that? You looked at your notes. So what happened here is that when we substituted in absolute value for x, it turned it into an absolute value function. Does that make sense?
No. Also, if the absolute value of x is going to be an absolute value.
In the linear, for linear, it will.
Yeah, that's what we're learning about. So we can just put that on our paper right now.
Okay, well, we're going to describe what happened. So a little more description. So, why?
Because I don't get it.
What happened? You just told me what to do.
I don't know what I
You told me how to graph the absolute value function. Trust the process. We'll get there, I promise. All right. So here it's saying explain what happened. So compared to the red one, so the line compared to the green, what is something you know? Snapped in half. Okay, that's one way of putting it. The green and the red. Your range changed? And why did your range change? Okay, I took the absolute value of the x's, right? So all of my absolute values of my negative x's, if I take their absolute value, they're going to become whatever their positives are. Does that make sense? Yes. So right here, when I'm at -2 and I plug -2 in, -2 becomes a what? A +2. So it's just going to mimic the behavior of whatever +2 is. When I take -4, plug -2 into here.
Oh, I get it. Okay.
What is absolute value of -2? 2. What's half of 2? 1. What's 1 minus 3?
-2.
So -2 is now at -2. -2 used to be at -4, but after this transformation with absolute value, because I'm no longer just a -2, I now became a +2, my y values are going to match whatever my positives are. Because I'm taking the absolute value of the x.
How do you write that?
We're about to, but I'm saying, do y'all understand what I'm trying to say?
Yeah.
I heard a no. So, absolute value. Are you sure? Okay. So you're just telling me to wave the flag? All right. So what's happening is that for P of x, so we look at all the x values that are less than 0 of P of x, their y values become the same as all x values greater than 0. So the positive x values are now going to become the output for the negative x values. And graphically, what that ends up creating is symmetry with the y-axis. Graphically, you end up having symmetry with the y-axis. And sometimes seeing it in live action with Desmos makes it better. That's why we're going to go to Desmos and we're going to go through it, okay? Symmetry with the y-axis. That's what it says at the bottom. I can come back to it and it'll be symmetry with the y-axis. All right, so up first, we're going to graph our linear equation. Our linear equation is 1/2 x minus 3. Are we okay with that? This is just a standard linear equation with nothing happening to it, right? Okay, when we did our next function, it said it wanted us to take the absolute value of this equation, right? So we're going to take the absolute value of this equation. You have two ways of doing absolute value in Desmos. You can type ABS, or you can click the little keyboard down here and use the absolute value button. Okay, whichever way you want to do it is up to you. I'm an old school person, so I type ABS because that's what you had to do on the calculator. So I type ABS, it makes me happy, and I keep it pushing. Do you have to type ABS? No. Okay, so I'm taking the absolute value of that function. When I'm taking the absolute value of that function, I'm changing all of its negative y's and turning them into positive y's. Do we see that? So I took all the negative y's and made them into positive y's. That's what the absolute value of the entire function does. It takes the function and bring it completely above the x-axis. How do you do what? Press the home button. The little house. Okay. Does this help a little bit on the absolute value transformation? Do we see how we took the red and moved it completely above? And now we're here at this absolute value function. Yes? Mm-hmm. All right. Now, the next thing we had to do is that I don't want the absolute value of the entire function. I only want the absolute value of your x. So we did 1/2 absolute value. I will do it using the bar just so you can look prettier. Absolute value of x minus 3. So when we did that, or compared to the red, the right side stayed fine because that's where all of your positive x's are, right? And then all we did was reflect our positive x values across the y equals x. I meant the y-axis, not y equals x, sorry, x across the y-axis. Yes? Do you see what we did now? Does that make clarity? Yeah? Okay. So this is going to help us make a conclusion for all functions. So if I'm taking the absolute value of any function, the entire function, what is absolute value going to do to the graph of that function? It's going to make it go above the x-axis. So if I'm taking the absolute value of the entire function, all of that function is going to be above the x-axis. Does that make sense? If I'm taking the absolute value of just the x's, it's going to create what? A reflection of the positive values. The positive x values is going to create a reflection over the y-axis, okay? That's the conclusion that we should be able to make here. And then we're going to prove that conclusion by doing next example, okay? All right. Next example, we're going to do completely in the calculator. But we're going to write it out, huh? Example 2. Oh, Desmos, yeah. All right, so here we go. We have q of x equals x squared minus 2x minus 3. So we're going to graph q of x minus 2x minus 3 in Desmos. Got it? Up first, go back to my Desmos. And I'm going to get a new one, start new. Here we go. So I have x squared minus x, not a minus x minus 3. Do I forget something? Oh. 2x, there we go, Okay, here's my quadratic that I'm starting with. Are we comfortable? All right, I'm gonna sketch it on my graph. So I have -1, 0, I have 0, -3, I have 1, -4, and I have 3, 0 as points, and I can do this one too, as points to help me sketch it on my notes. Is that cool? I'm going to do -1, 3, 0, 0, -3, 1, -4. I'm going to need y'all probably to tell me these points again when I get to the graph. Okay, what are my points again? 0, -1. Was it 0? 1 or -1, 0? -1, 0. 0, -3. What else?
1, -4.
And 3, 0.
Sorry, I don't understand my person.
She was the only one that was trying to help me. I will take it. So, hey, that's the, yeah, like, I can't even make y'all pretend I went through those points. Let's try real hard to go through these points. It is the pen, guys. I am convinced that this pen doesn't want me to be great. Ooh, 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 ooh. This is the best it's gonna get. All right. So here is my Q of X. Are we good? All right. Now part B says you're now going to find M of X. M of X is A composed of Q of X. Remember, A of X is absolute value of X, right? So we're going to do, to find our M of X, it equals A composed of Q of X. It says right here, M of X equals A composed of Q of X. And it says, what is an algebraic representation of that? So M of X equals A composed of Q of X. So in the calculator, what am I graphing? So our graph is going to be Y equals on an M. Absolute value of X squared minus 2X minus 3. And that's because I'm plugging whatever Q of X is into the absolute value bars. Agreed? All right, so we're going to go graph it and see what happens. Before we go graph it, what do we know should happen? Exactly. All of my negative Y values should go above the X axis. Yes? Okay, so we're going to go and see if that's what happens. So we're going to go here and I'm going to type in absolute value of X squared minus 2X minus 3. Did all of my negative Y's go above the X axis? It did. So what my red, so all from -1 to +3, all of their negative Y values now became positive. So now I'm still at -1, but now I'm at 0, 3, 1, 4. What is that? 3, 0. And that's my new. Yep, so we're going to graph it. So we're going to go back to our graph. So you stayed the same because you're 0. Negative became a positive. This negative became a positive. This negative became a positive. And you stayed the same because you are 0. So my graph looks like a W. And that is my, oh. I didn't even say that was good, y'all. Didn't even say it. I was way away from that red line. Let's try that again. Follow the red. Follow the dots. Go. You can do it, Trona. Go, go, go. And that is my M of X. So Explain what took place. So all the x values between -1 and 3 of q of x, their y values became what? Positive. That's what happened mathematically. What happened visually? It made a W, but all values are above the x-axis, right? Graph is above x-axis. Yes. All right. Now it wants us to only, it says a of x is still absolute value of x, but our n of x is going to be q composed of a of x. What does that mean? So if we have n of x equals q with a of x plugged in, that means q with absolute value of x. So what am I graphing? Y equals what? I'm replacing all of my x's with absolute value of x. So there we go. Y equals absolute value of x squared minus 2 absolute value of x minus 3. The square goes on the outside of the absolute. Because it's just the x's being absolute value. Okay? Based on what we learned, what should happen to this graph? Okay, what do we call that? What did we say it needs to have? Symmetry. It's going to have symmetry with the y-axis. So we should be having symmetry with the y-axis. So that means we're just going to symmetry this way. Let's see. All right, here we go. So we have absolute value. I'm going to use absolute value bars of x, and it's going to be square minus 2 absolute value of x minus 3. And did it create symmetry with the y-axis? Do we see it? So our points are 3 didn't change. 1, -4 every year. We don't grow up. Okay? It created symmetry with the y-axis. That's because all of my x's are going to become positives, so they're going to have the same output as their positive x value counterparts. So from the graph here, I know that you're going to stay the same, you're going to stay the same, you're going to stay the same, you're going to stay the same. But the symmetry is going to be on the other side. So at -1, it's going to be -4. At -2, it's going to be -3. At +3, it's going to be 0 because it's going to create that symmetry. And this side is going to stay the same. So here is my n of x. For this one, all of our x values, so the x values less than 0 of q of x I'll come back. X values less than 0 of q of x equal what? Equal y values of x values greater than 0 of q of x. Okay? And our relationship here is visually symmetrical with the, I don't know if I spelled symmetrical right. Symmetrical with y-axis. Okay? So what you are going to be doing for your due now on Monday is you're going to be doing the exit ticket. Your exit ticket, you're going to create your own f of x. It must have an x in it. And you're going to apply both compositions. So you're going to apply f of x composed of a of f of x. So you're going to find a composed of f of x. And then you're going to find f composed of a of x of your own creation. Okay? That concludes our notes. All right. And your assignment. All right. You're creating your own f of x. So you're finding your own, you're going to make up your own f of x. So any function. And then you're going to apply the compositions and graph it. All right. And then you have your assignment.